Alright, here's the setup here. Let me just show you. I've got this adapter to a Capto taper mounted in the spindle here in the chuck, indicated in. And I put a collet chuck in that with my dial indicator in here so I could rotate around and get this thing indicated in. Now I set the machine. Let me get the camera closer here so you can see the indicator. I set the machine here on Y0, and then I tapped this around until I got it to indicate true on Y0, so I don't have to mess with any kind of funny fixture offsets. And I want to bore it this way so that when I go to mount it again, I'm going to have to take it off and put it back on. Anyway, I can line things up the same and everything should work out the same as far as that goes. Then we've got the dial indicator here. I'm going to put it on a 0 point here. This should be fairly close to being right. Although you really can't. Let me see, maybe I can hand hold this thing and you can see it better. I don't know if you can see that all right, but anyway, we got the attachment thing, mounted the housing on here onto this piece. I had to two of these things, the guys that made these in the shop made these all identical, but the hole spacing, the hole in these spacer things is not the same on all of them, although they made them kind of duplicates of each other, and that doesnn't work, so we're gonna have to remake these too. But anyway, everything else seemed to go together okay. And now we're going to set this as our fixture offset 0, 0, which I think I already did. I've got these set at 0 in X and Y. Then I'm going to have to mount a boring head in here and bore. First we're going to bore the small bore all the way through first. And make that a nice close sliding fit on the small bearing on the end of the spindle. And then we're going to set up and bore this larger one with the same boring head. We just got to put bigger diameter tools on it. This is a little bit, not that bad, but a little bit tricky the way this actually has to be programmed to do this on the machine, because the machine, how do I explain this? The machine thinks that probably I'll program as if it had a drill in here, a stationary drill, and it's rotating the turning spindle to drill the hole. We're just going to use actually a drilling cycle or a bore up and a bore back cycle type of thing. And we'll be doing it in reverse, but the machine doesn't really know any better. It just will do it as long as we tell it the spindle is rotating here and not the milling spindle. In fact, we're going to have to, I'll put the blank I made for the shiv in here, and we'll clamp it like it's a lathe tool. So it thinks it's a lathe tool in there, a stationary drill basically, but it's going to actually be coming to this position to do the cycle, and just going to bore up and bore back, and then we're going to keep readjusting the boring head until we get the diameter we want. So first though, we're going to have to set up a dial bore gauge to that diameter, and then we should be ready to go, well, once I set up the tool, of course, and touch the Z0 off to the face of the part here. Right, we need to determine what we're actually cutting the bore to, so we need to set up a dial bore gauge. First we need to measure things a little bit here and see where we're at. Okay, this micrometer actually reads, let's write this down, 2.407. That's what the mic's reading, but that doesn't necessarily mean that's the right size. We got to check that. just to be sure. Do it again. Yeah, okay. 2.4407 is what that mic is reading. Now we got to set up a stack of gauge blocks. That's that height. Let's get the gauge block set. And let's just double check, first of all, that that micrometer is reading the right size. And then we'll verify the mic, and then we'll actually measure the actual size of the bearing. So we're going to need, obviously we're going to need a 107/10,000ths gauge block for the smallest size. So that's the smallest increment here. And then we're going to need a 140,000ths gauge block right here. So that's going to be our 40 thousandths and our 7/10,000ths setting. This is kind of the way you stack up gauge blocks here. And then we're going to need, we've taken 240 and 7/10,000ths off of this 400, so we're going to need a 200,000ths gauge block. Ring that together. I like the way that felt. Okay. So that's the 400, the .4407 stack there. And then we're going to need the 2-inch gauge block. All right. That is going to be what that dimension should actually be. Now let's check the mic and see if it's really measuring that size. And it looks like it's measuring about 1/10 of a thousandth less, maybe 2/10. It's really measuring, our micrometer is really measuring 2.4405 for that size. Now I think we're going to have to adjust his mic just a very slight amount. Let me check the setting on this mic just to be sure, because it seems to be off just a little bit. Let's yeah, see, the 0 is off just a hair. Should have checked that first. So I'm going to adjust that. This little wrench here. Okay, that looks pretty much dead nut on 0. I'm going to take the something that's close to our dimension here, the 400,000ths gauge block. I'm going to ring that onto the 2-inch gauge block right now. Should have actually done all this first before I started here. I'm going to go out to the 2.4, make sure my mic is reading 0 there. It's pretty darn good, it's right on the 0. So now I'm going to actually remeasure this this bearing. I should be getting 2/10 smaller. I should be getting something closer to this size here. Okay. Now we're reading okay, we don't care about these numbers. We're going to get 2.4405 2.408, it looks like, is what we should be setting our gauge blocks to here. So let's got to take this one off of the end, the 7/10,000ths, put the 108/10,000ths, and this should be the actual size this bearing is. We're probably going to want to bore that board just a tenth or two bigger than that. Just make sure that we're our mic is reading that size. We measure this. Check it one more time. Kind of, in a way, handling this micrometer kind of a lot for this. Just the temperature, my hands could be screwing things up here at this close of tolerances. Try not to hold on to it too long. Okay, let's kind of slide that on the bearing. That looks pretty good. We get the fit at least that, and maybe just a tenth or two bigger, will be where we want to be. She's okay. The micrometer and everything's comparing. So this is our stack. We got to set our bore gauge to right here. Let's move the gauge blocks out of the way and get our anvils. The Mitutoyo anvil set like we used before. I'm going to get these two and something to clamp this whole mess together with. Something like this and one of these things. Put this over here, get it out of the way. I'm going to ring the end pieces on here. This one. I usually start these square gauge blocks right off on the corner and just run it up in there like that. Everything lined up to the holes. See, whenever they're rung together properly, they shouldn't fall apart when you lift them up. Stick this through here to just clamp everything together. That should be our stack. Now I have to go get a dial bore gauge with the appropriate anvils and everything on it, and then we're gonna adjust the zero of it. Alright, the way you normally do this is, you know what dimension you're going to here. Let's take this apart. We're looking for the appropriate anvil and shims for this. I've got a whole bunch of dial bore gauges all mixed up here because I've got a lot of these things, and this is not the only set, but this particular gauge is the 1.4 to 2.5 internal diameters. So we got to look on this chart, which is this one right here. Actually, I know you probably can't read this, but what I'm looking for is something in the area of this dimension on this chart, which is going to be 2.44 down here, 445, 2.445, or 2.417 to 2.465. Okay, here it says I need the number 6 point with the 80 thousandths shim. So that's what I'm looking for. The 6, which is going to be this one. This is kind of a combination set of, well, if it had all the gauges in here, they're in my toolbox, but and this is the 1.4 to 2.5 set, which is this one, and we want the number 6 anvil, and we want the 80 thousandths. These are kind of all mixed up. I gotta measure it here because I don't think they're sitting in the right places. So that's the 80 thousandths shim. So that's going to put us in our range, in theory. We'll see if that is. So sometimes this doesn't work out perfectly the way I like to set my gauges here. We'll see if it works out. But it's going to get you close. So when you swing the gauge in here, you're not going to be out of the travel of the indicator. Let me see if I'm in the range here I want to be. Okay, and I'm going to set this aside here a second and get this out of the way so we can set this up properly. Now, in the comments last time on the previous video, somebody said you should set the gauge with the stationary anvil down and your indicator up, but in reality I don't set them up that way. I like to set them this way, and normally I do this up vertical, but I'm going to do it horizontal so you can kind of see the dial indicator here and what I'm doing. So you get your gauge in between your gauge block stacks, and you swing it back and forth both directions. I normally do this up here from the handle of the gauge, but you can do it down here too. In reality, if you're really working at close tolerances, you don't want to be putting your hands all over these gauge blocks. Let me see if I can do it the way I normally do it. If I can somehow show that in the camera. Let me turn things around here. See if I can move this. Maybe I can do this. Let's see. Because I normally do it this way because it's just a little bit easier for me to do it this way. And the person that made the comment about setting the solid anvil down is correct. That is the best way to do it. But it also, with these, when you have a long gauge, like let's say you had a long gauge and you had extensions and you're way out here or further, yes, then that weight of this thing is going to come into play. But if you hold this gauge by its handle and you're measuring, it's pretty much balanced. You see, if I hold it right about here, it's pretty much balanced. So when I'm measuring my bore, if I'm holding onto this plastic handle, the weight of things is pretty balanced, and it's not going to really make that much difference. And in practice, I haven't noticed it making any difference at all. In fact, I set this thing up vertically usually. I'm trying to do this around the mag base that holds the camera here, and it's kind of a little bit awkward. But what I try to do is I swing this back and forth both directions to get my null position on my indicator. Actually, I kind of hit that almost perfect right off the bat. I don't, just lucky, I guess. And I want to set my 0. And what I want to do is the small needle here, which shows the revolutions of the larger needle, I want that to be on the first division, which is the 1, and I want my 0 to be on 0 when that's on its first division, like it is there, just like that. don't know if you can see that. I'll run it closer up here. So you swing this way, get your null position, and then you twist the gauge in the blocks to get the null position both directions. Then you set your 0. Actually, my 0, because we're dealing in so intense, I want that to be exactly right on. That way and this way. So that would be my, and tightening this, if you tighten this too tight, you can actually change this whole indicator's reading as well. You gotta be kind of careful with that, as well as this one and that one. Everything puts force on this gauge and makes things change. Okay, so that's our 0 point for this stack of gauge blocks we set up. So now we've got the gauge set up, and we can go over to the machine and put our boring head in there and everything. I've kind of got to get a rough diameter set, because I think that actual hole that's in the aluminum part is not, I think it's small. It's quite a bit smaller, like 100 or 150 thousandths smaller than the size we're boring to. In fact, right now the boring head kind of won't fit through there, but our first cut's going to have to be a deep enough cut to get the boring head itself to fit through there. So we're going to be using, actually I can show you. We're going to be using this boring head. We'll go over to the machine and set this up on these extensions in the spindle of the lathe. I might be able to take one of these extensions out. I got to check by the time I get the actual cutting insert holder. We're not going to, of course, use this boring bar. We're going to have to use a different one on this. And we want to set the stroke of the boring head back, or centered in this case, sticking out a little bit. We've got a tight clearance problem going the first pass through this bore. So we're going to have to center this up so the boring head is no larger than its actual diameter, because the actual diameter of this boring head, I think, is like 50 millimeters actually. So, which is just a little bit less than 2 inches. I think the bore in the part might be around 2 inches right now. So we got to come out. We got to come out to this dimension right here, maybe plus 1/10 of a thousandth or so bigger than that. So let me sort of get this tool kind of roughed in the settings, and we'll get back with the camera on the machine. Also, running the machine this way, it's kind of how do I put it? It doesn't, there's no way to put coolant on the tool running backwards like this. And the way I've got the thing mounted on that spindle, I haven't got the seals in there and everything, so I can't use the coolant. So I'm just going to have to like spray, but this is aluminum and I could probably get away with it. I'm going to spray some WD-40 or something in there and close the doors, because I can't, on this machine, remember, I can't run anything with those doors open. So once the doors get closed, we got to do everything with whatever is in there. So let me get that all kind of prepared, and then I'll be back with you at the machine. Okay, I've taken one pass through here. I was a little bit nervous about doing this, and so I did it without the camera, just so that wouldn't be a distraction. But now that we've taken one pass, I'm going to measure. I can't measure it up here yet because the bore isn't that big, but right here looks like we're at 1.145. We've got quite a ways to go yet, because we're going to, what are we going to here? 2.160. Excuse me, not 2.160. We started, I set the boring head about roughly at 2.160, cut a little bit undersized, but it might be that it was taking quite a pretty big cut. Let me check this again here. 2.145. And I think I set this up on the boring head, so I think I have enough adjustment here. What we're doing here I put this boring head in this Capto extension thing. Let me move this over so you can kind of see it. So I have this Capto extension mounted in the 4-jaw chuck. I made this thing to be able to mount Capto holders and do various things to them, mostly turning blank holders and things like that, or modifying holders. And so I've got this ITS C8 to ITS what is it, this MB50 connection like I put in the spindle, and then I've got a couple of extensions and then a ITS boring head here, and the just this bar with the CNMG insert on the end of it. We're boring this thing out now. Like I said, I think I've got enough adjustment here to where we can go quite a ways with this. So I'm going to go, each revolution of this dial is 4,000, so I'm going to go 4, 8, 12, 16, 20, 24, 26, 32, or 28, 32, excuse me. $40,000, so that should be about 40, we'll go another 4, 8. That should be almost a little less than 50 thousandths if I counted that right. Doesn't matter, we're not really even close yet, so this should be all right. I'm going to jog this back over this direction. This was a little bit nerve-wracking to run because you actually have no way to put coolant in here, by the way, yet. So I'm just going to spray some WD-40 in there. We're actually running in sort of in reverse here as the way this machine likes to run. So basically what I'm doing is telling it thinks up there, really, the spindle up there, the milling spindle, it thinks there's a drill that's clamped and it's going to be turning the turning spindle to drill the hole with the drill that it thinks is in there, but actually I've set the 0 point at this center of this bore like you saw earlier when we checked it. And now let's close the doors here. I'm going to start the program. It's just a very simple program. It's just one boring cycle. It just bores in and bores back. That's all it does. But it's a little bit weird to run this because it's actually doing it with the lathe spindle. So it speeds it up, 1500 RPM. The actual maximum RPM this lathe spindle will turn is 1600. So turning at 1500 here to do my boring. I haven't even got close to being able to check it with the dial bore gauge. I got to get out a lot closer to the diameter to be able to check that. You can kind of see I don't know if you can see that on the video, yeah. You can kind of see the smoke coming off of the WD-40 as it's cutting the material. So it's just basically going to feed in and feed back, and then it's going to move back in Y at the end of the program, and that's it. Really have no, got to be careful not to have any tool changes in the programs with this thing, because obviously it can't run that thing up into that tool changer. You have a big crash. So just about, okay, now we're coming out. I told it to go 100 thousandths beyond the end of the part there. part's 7.5 inches long, and we're going 7.6 inches deep with this. Basically, it's a bore in and bore back cycle. Nothing really special. And we just got to keep adjusting that boring head out to where we get closer to the size, and then do some finish cuts. So I'm going to be kind of conservative here. I'm going to take many passes at it. I'm probably not going to show you all these. You get the idea. It's going to look the same. So I'm just showing you this pass, and then we're going to come back when it's closer to the size, when I'm actually measuring it with the boring bar, or the dial bore gauge. I can't even speak correctly. Okay. Can't open the doors until that spindle stops completely on this machine. Even though it's not actually running the spindle. Let me blow this out. I don't know if I can maybe show you a little bit if I get some light behind there. So right now, it's not cutting here yet at all, just cutting back there. This bore is going to be larger for the angular contact bearings in the front here. But by the time I get that out to size, it'll pretty much cut this right now. And this gets cut just a little bit bigger, like another 100 thousandths per side for the angular contact bearings. So anyway, that's what I'm doing. I'm going to run this quite a few more times. There's no sense in you watching that every pass. And I'll come back when I get closer to the size we want to deal with here. All right, let's see where we're at here. Back way where the bearing's going to be sitting. I don't know if you can see that. That's about, I don't know, 1.5 to 10 thousandths. It's about 2/10 under our nominal size. Out here, it's just a hair bigger that direction. Let's see. A little bit smaller that way. It's about the size we want. Let's just see back in the back there where the bearing's actually going to set. It might be good that it's a little bit bigger in the front by 1/10 to get the whole thing in there. Man, that's still pretty tight. I'm going to deburr that a little bit. I don't know if you can see what I'm doing here. Let's see. Hit that with Scotch-Brite a little bit. Even that burring tool will leave a burr, and I can't get the, might not be able to get the bearing started. Okay, let me see if I can get this thing started in here. Okay, yes, that actually goes in there. Wow, it's just about the perfect fit. Let me see. I don't know if I could stick it in from the front here. Let's just see. Yeah, that's about the way I want the fit. Wow, that's close. Okay, so that bore, I think, is done. If anything, I don't want to take it any bigger than that. Now, I got to bore this front section out bigger for the other bearings, and that's pretty much the same kind of thing. I don't think I'm going to take you through all of that because it's just the same thing. It's just a bigger bore. It's a little bit shallower. And there's no need to bore you with all of that because it's the same exact stuff. Looks the same. And I'll come back with the video after I get that bore to size. I'm going to set a new dial bore gauge diameter and everything just like I did before, and I'll adjust the boring head such that I can get out to that size bore for the front there, and we'll bore that, see if we can get this whole bearing, this whole spindle cartridge to fit in there. So I'll be back with that. I just finished boring this, and I stuck the spindle in as far as I can. I can't stick it all the way in because there's no thread yet, of course. And I put this 10th indicator in here. I just was curious to check the run out of my whole bearing setup and the way I built the spindle. And see, I'm turning it from the other end here. I don't know if you can see that. That's a 1/10 of a thousandth indicator. So each one of those divisions is a 1/10 of a thousandth of an inch. You can see the run out is less, well, maybe a 1/10 of a thousandth on the bore there. And now, of course, it isn't screwed in tight, so there's not really the proper preload to the outer races yet, but if I push down on this, I can deflect it, but it pretty much comes back to its original setting on the indicator. So that looks pretty good. I'm pretty happy with that. In fact, it's a lot better than I thought it was going to be as far as the run out on the spindle taper. I turn it from the back end here. So when I get this thread in here, now I probably have to, like I said before, I don't see a decent way to do it with this setup here, although it would be ideal if I could somehow mount a thread mill. I could do it. I have the tooling to do it. If I used one of these, If I used one of these ER holders, I could mount it in there. I could actually shorten this up and mount it way up here, maybe directly in the adapter from the Capto to the the ITS MB50 taper, which is what this spindle has in it. And that's what I got these things for originally, so I could mount them in here. But I could do that and mount a thread milling cutter in here, but the difficulty is programming it. Well, actually, I might be able to program it with this spree, all right, but getting the machine to run it, because it doesn't like to run the lathe spindle unless you have this tool, which right now I've got that blank that I've machined here clamped in the spindle as if it's a lathe tool, so it's oriented and clamped solid. And I would have to leave that way in order to run this spin, you know, in order to run the lathe spindle over here. And I'm not sure how to get it to do that. I mean, I could program it. I could program a milling tool as if it's in this spindle here, and program the thread mill cycle, and then put the thread mill in here, and maybe it would do it. But I'm not sure how to get the lathe spindle to run with the thread mill in there, and then do it, you know, with the compensated tool path and everything to cut the actual thread. I have to think about that and see if I can make that happen somehow. Maybe I can manually edit the program to make it turn the spindle on and clamp this one up here and do it. Okay, I think I've figured out how to make this thing mill this thread in here. It is a little bit confusing, to tell you the truth. I'm being very conservative the way I'm doing this. So if the feed rates look real slow and everything, it's because I haven't got a lot of confidence in what's happening here. It's very confusing. See, when it's over there at the X0 point, it's in a diameter or a radius mode. But on the display, when it gets up there all the way at the top there of the circle, it's in a diameter mode. It's reading a diameter up there. And when it gets right about, it's almost there, it reads on a radius direction in the y-axis. It's ultra confusing. And I'm stopping it every time here to blow off those shavings because I have no way to really put coolant on this right now. The whole system isn't hooked up for that yet. So here I'm stopping it right here at this pass. I'm standing off of this thing quite a bit right now too. It's got a lot of extra stock I'm leaving just to see what's happening here. But I've kind of checked this over and over again, and I think I've got it working right. It's very confusing because when you're milling on the back side of the hole, if you will, like this, with the spindle, you have to mill a left-hand thread to get a right-hand thread if you want to climb mill it like I'm doing it from the bottom up, if that makes sense. But it's kind of, like I say, kind of confusing. And I've looked at the numbers over and over and over again, and this appears to be working. Probably should cut a chamfer on the beginning of that bore, but I'm not going to worry about that right now. I'm just going to get this thread in here. I might just do that by hand on there with the deburring tool. Okay, there's another pass. It's making 5. It should be making like roughly 5 passes on this thing. I don't know, 4 or 5, I can't remember. So this is the third. I started you off with the video here on the second pass, so that's the third pass. Let's blow this off. It looks, so you got a right-hand thread goes in that direction, even though we're milling a left-hand thread here, like I said, because we're on the back side or the bottom of the hole. So one more pass. I think there's 2 more passes maybe total. The last 2 are kind of like spring passes. And I've got the cutter diameter big here in the cam software. You can't use cutter comp on this either. Obviously, you couldn't use cutter comp if it's actually reading the diameter. When it's down at the bottom there of the hole, which is the plus in X, it's reading a 2.4, right at 2.4 inches. If you add the cutter diameter to that, you come out with 2.75, the thread, 2.7514 thread. And then when it's over here, it's only reading at 1.2 something. It's like it's very strange. I've never seen numbers on the display like this. Right there, just past 2.4, and we're coming up on a 1.2 inches in Y right there, just half a 2.4. I'm not really sure why it's doing that or how it can even do what I'm doing and keep track of that helix. The program isn't showing that, but the program is showing the correct numbers, but for some reason the display on here doesn't like it. I think it thinks it's in the lathe mode because of the way I'm faking the machine out, and so it I'm gonna wipe off the. I've got the camera real close, blowing those. Okay. We've got one more pass to go here. And we're going to come out and come forward, and we're going to take a look at it. I ran it out in front of the part a few times just to satisfy myself that it was actually doing what it's supposed to do, because it's, like I say, it's kind of confusing. This last pass is kind of on the threading cycle. I've selected for it to do 5 passes. The first 3 are working out in a radial direction. First pass is 60% thread depth. The next one is 30%, and the third one is 10% more, which then adds up to 100%. So the last 2 passes of a 5-pass thread cycle like this are just spring cuts. That's typically the way I do it. So we're almost done here, and then we're going to come out here. We're going to kind of check things over. Then I'll have to go back to the computer and reprocess the code with the appropriate tool diameter. All right, let's look at this here, see what we got going. I'll wait for the doors to open here. Reposition the camera so you can kind of see what's happening here. So that let's get my thread pitch gauge here just to double check that. Find the 14. This is supposed to be a 14 pitch thread. Let's see here. Trying to find this. 12. Other side. There's the 14 one right here. Okay. It's definitely a 14 pitch thread. See, this is my part that's eventually going in there like this. 14 pitch thread there. 14 pitch there. I don't think it's out to size yet, obviously. Man, there's so much. Let's just check it just to make sure, but it shouldn't be out to size. No, won't even start. Okay. It's close, but it's not starting. I mean, it starts, but it's not going in. Okay, I gotta reprocess the code with a different tool diameter. And we have to run it again. Finally, I had to take one more pass at it with 2 more thousandths off the cutter, and now it threads in fine. So that works pretty good. Let me assemble the spindle back together and stick it in there and see how it looks in there. We need to make sure everything is pretty much clean in here. Okay, let me get the spindle back. All right, I got the spindle back together. I'm going to put a little touch of oil just to make things to go together easier here. The WD-40. I've got the spindle cartridge thing, or whatever you want to call it, here. Get it lined up with very little clearance here. And have it just right. Now, might be that I got a burr on that thread. There, let's see. The end of that thread maybe doesn't want to allow me to go in there. Something here, piece of Foreigner grit paper here. I'm gonna have to clean this off real good, of course, before I actually put everything together, but hit it with some Scotch-Brite here. the idea of this thread is just about the same as the idea of the OD of the bearings, I should say. This isn't really going to be the final assembly of this thing. Don't worry too much. I'm just going to check it to see the bearings. Had somebody ask in the comments about, was not worried about getting dirt in the bearings, but the bearings have seals on them. I don't think any dirt will really get inside by those seals. I'm being sort of careful. Let's just see if we can get it in there now. Get these spacer lined up. I might have to. The spacers don't seem to be very tight. I really want to. If there's maybe just a little bit of a burr. Start this thread here. A little bit tricky to get this in there because it's want to get cross thread the very first thread on this nut. Once I get it in there a little ways. Should be able to pull it in with the thread. Maybe that's enough. Let's see. This is. I don't really want to. Get too carried away on how tight I tighten this. Everything is going in there a little bit snug. If I tap on the end of the spindle here, it kind of you can see why I kind of need that thin wrench now on here. Okay, that's up against the bearings. That's pretty much solid in there now. Yeah. Spindle feels real nice. I have the end cap. Oop, sorry. Kind of bumped the camera there. I have the end cap here that goes in the end, but I've got to put a little clearance on the beginning of it here because it's hitting that that washer, you know, that lock washer, star lock washer thing, just barely dragging on it. Let's get a dial indicator. I don't know where I can stick this thing on here. I don't really want to put it on the same deal that the camera's on, because it kind of shakes around a lot. Back this up a little bit more, see if we can see that indicator, see what our run out is here with the nut kind of tight. Gotta watch myself over here, don't hit something by accident. Let me clean this out a little bit. All right, now we use the jog function here to get on the indicator. I don't know if you can see that. It's pretty good, you know, I guess you can see it. Running out 1/10 of a thousandth, more or less. You just push down on it and see what happens. These bearings are a light preload. I might have to grind that center spacer a little bit shorter, put a little bit heavier preload on this for the application that I'm using it for. Okay, that's not too bad. I don't know if that looks clear. Can you see that indicator? Maybe if I got a little bit further away, because this camera doesn't really focus that good super close. Let's see. Maybe that's a little bit better. Let's bring this on to 0 with the jog of the machine. Maybe the stylus on this indicator is a little bit loose or something. Anyway, looking at that, turning it on the back end here, the spindle, less than 1/10 of a thousandth on the bore. Let's see what this taper does. I thought about re-skimming this taper. Let's see what happens here. I'm going to put the indicator on the actual jog the machine up into it. Okay. Now that's running out a little bit more. Maybe a little more than 1/10 of, maybe a 1.5 10,000ths. I don't know, about the same maybe. Not too bad. It's probably not enough to worry about. I mean, it depends on, I don't know if my indicator, so that actually came out a lot better than I figured it would, to tell you the truth. I'm kind of amazed I got that good with what the setup. I was having a little difficulty with that setup when I was doing this, turning the spindle and everything. Now somebody mentioned something about putting an adjustment on it, but see, if I loosen this bolt here, this screw, I can raise the whole housing up and down. Right now, if I put the gear or the pulley, let me get the pulley here and the belt. So if I put the pulley up here on the you can't see that, can you? I don't know if you can see all that. Might be able to see it now. Well, let me move it back a little further here. So if I put the pulley up here, it's not glued on yet. Like I said earlier in the previous video, I want to wait on that until I get everything lined up here. See, if I loosen this bolt, now that I got everything done here, I don't really need to worry about this losing alignment or anything. So if I loosen this bolt here, and I guess I got to loosen it more. The people that milled this slot made it awfully tight here. I'm going to have to well, maybe my model was kind of tight too. Maybe I shouldn't be so quick to blame it on them until I figure out if it was me or them. But anyway, I can adjust the tension on this. The slot in the back of this aluminum piece, this spindle thing fits real close in it, so that's probably not as tight as I'm going to have it, but once I get the tension right, I shouldn't really have to change it, because I can just take this in and out of the spindle. So I put the belt on and put that in there, and hopefully this belt will track. So what I need to do is get this. Actually, this hole is going to be pointing straight down, or if I put the boring head, I mostly want to do this for the sake of a boring head. Show you what I'm talking about here, because when I have the boring head in here, if I ever want to do like a bore orient retract, the boring head faces down this way, and so when the spindle is oriented in the appropriate way, the milling spindle up here, I want this shiv to be glued on there in such a way that this is vertical like this in this position, which means that hole that clamps the tool in here is facing straight down. This hole faces, I don't know if you can see that, but see the arrow? That's the direction the boring head adjusts. So when this machine does its bore orient retract, it lifts up in the x-axis. Well, you could tell it to move any direction, but normally it would shift upward and then pull the tool out on a bore orient retract. So I want this, I'll indicate this vertical like this, and then up here I'll put some kind of mark on this shiv and the adapter, and then I'll glue that on there so that this will be fairly close to being oriented when everything is working properly. I don't know if I could, if I unclamp this, see, it'll rotate this. I don't really dare run this without this thing glued together here, because it might spin in here and gall it up, but that's the whole idea here. If I rotate this by hand, you can kind of see the spindle rotating there. So this is going to drive the parallel spindle, I guess you call it. This is a 1-to-1 ratio, so everything should run the same speed. Whatever I program here on the Mazak's. You know, this spindle, it should run this one down here at the exact same speed. And we'll see how good this belt works as far as you know, strength wise and noise and everything else, smoothness. It's supposed to be it says it's a silent sync belt, so we'll see how this works. And initially I'm just going to try to get by with this Loctite on both of these sheaves. I think that should be fine. If I can't, for some reason, like something moves here, I'm going to have to put some pins in here. And I've kind of thought about how to do that. And I think it shouldn't be too big of a deal, but I'm going to try to do everything without that. So anyway, that's pretty much the whole deal here for this this particular video. I just wanted to bore this out and thread it. The threading operation was kind of tricky to do, but I eventually got it to work, although I'm amazed it did, because the readout on the machine doesn't read anything like it's doing it, but the program itself was going to the right numbers. So anyway, and I think we're going to be all right here. I got a little more adjustment on the belt if I need it. On here, this end of the spindle, on this end, gets this cap thing that covers up this, but right now it's kind of drag. See this star washer thing? It's kind of hitting here. I got to increase the size of this bore a little bit. It's hitting on there, but. And I specified the wrong size holes to drill here. I got 1/4 I got to drill those out. That should be easy enough to do on the drill press or something. But this thing itself is got to be opened up just a little bit on the ID here. But other than that, the spindle isn't permanently put together yet. I've got to decide what to do. I think I'm going to grind about 1/1000 of an inch maybe or so, I don't know, off that middle spacer to a little more preload in the bearings. These bearings, if I remember the specs, were rated to run up to 20,000 RPM with the preload they have, I guess, is what that means. But I'm never going to run this that fast, of course. I'll probably maybe a maximum of 3,000 or 4,000 RPM I'll ever run this thing. So it shouldn't be a problem if I increase the preload on those bearings, I don't think. So anyway, that's it for this this part of this assembly. I've got to remake these. They made these identical, 2 of these and 2 of those, but I told the guys when they were making them that all of these were different on the hole locations, so they don't match up to my bolts. So I temporarily put these threaded studs in there and held this on to do this machining operation. I have to I have to remake these, or they're going to do it, the other 2. And then I got to assemble all the belt guard things and put the spindle permanently together and everything. And this thing should be pretty much ready to go at that point. So if you have any questions, thanks for watching. Put them in the comments, and thanks for watching.